Okay, let us start our discussion on concavity and convex of the curve. Concave up means it is called convex, concave down means it is concave. Okay. See here, what happens actually? Suppose we have a curve y is equal to f of x. That is called, we can say, it is U-shaped curve upward U, that is called concave. In order to say whether the curve is concave or convex at that particular point, we can say that. How can we tell that? Suppose they given the curve who do and point is given x comma y, they ask to find out whether the curve is concave up or concave down. Concave up means it is u-shaped at that curve, u-shaped up, and it is just like a convex means, I can say, the smiley uh, space like this. Okay. And concave down means something, we can say like this, you up, the curve is below the table. Anyway, if I say the convex means at that particular point, if you take small portion of that point around that point and draw tangent at that particular point, what happens? If it is concave up means that the height of the tangent in around that, I can say that it is below the height of the curve. It means that what I want to say is that whenever the curve is up, if you take for example y is equal to, we know that there is a point is given. We know the slope of the tangent is, I can say, easily find out. You can say that if y is given, dy by dx is equal to f dash of x, and I want to find out the slope equation of the tangent is nothing but the y minus y1 is nothing but the given x comma y point, y minus y f of x is equal to x minus x1 here. Here x is given. I'm going to choose another point x plus h near that point, around that point, just a very minute change, that is x plus h minus x, that is called h, you can get it, into f dash of x, can get the equation. By that, what we can get, what is the height of the tangent uh, at that point from x to the x plus h, that minute change in the h, x from x to the h, what is the height of the tangent we are going to get this point. Okay, that is f of x is the point, and we can get by this formula. Similarly, if you find out this height of the curve from x to the x, we have to find out the height of the tangent from this formula. Similarly, if you curve actually the nearby that point from x to the h, what happens? Whatever this point, what is the height of the curve that is given by, I can say that Taylor's theorem, x plus h is equal to f of x plus h into f dash of x, h square by 2 f double dash of x, plus even smaller terms like that, you can get it. But if you difference of f of x plus h minus y means the height of the curve minus at that particular point nearby height, that minus height of the tangent becomes, if you get the difference is what we can get, this height of the curve is nothing but f of x plus h f dash of x plus h square f double dash of x minus f of x into h. This will going to get cancelled. Only the we can get is h square plus some terms are there we are going to neglect, because why we are going to neglect there, even though if you make it deduct it, because their contribution is very less, therefore we are going to approximately equal to h square. Then this will going to decide how this is concave up or concave down. If f double dash, since we know that h square by 2 is always positive, then we no problem, this quantity is positive. If f double dash of x is positive, then the f of x plus h minus y, I can say that it is greater than 1. Definitely f of x plus h means the height of the curve is greater than height of the tangent. Means the curve is concave up at that particular point and both the sides were calculated. You may, the one question comes, why f double dash of x, the other f third derivative one, they may make this thing negative? No, because they are negligible. Their contribution, if you want to h going to become h cube, h4, like that, their contribution going to be decrease, and therefore they are not, the sign depends entirely on f double dash of x. What I want to say is that in case the f double dash of x 0 means, what we can say that second order derivative is, I can say that, is f of x plus h minus y is greater than 0, the curve is above the tangent we can get. And if suppose f double dash of x less than 0, the curve is below the tangent, I can say that. Means the curve, we can say that it is concave down. Like that, we can conclusion. One question comes, third order derivative, fourth order derivative. Then, even though, because that in Taylor's theorem, we can go further here. But what happens? Their contribution only the, even though if you deduct all those terms from this, then it become never negative, because their contribution is going to become uh, very less. Their contribution becoming very less. They're not able to make it uh, negative and 0. Therefore we can say that if it is positive, it remains only positive. The remaining terms will not affect this f double dash of x. You can check with an example, no problem, you can understand. We can say that therefore the entirely depends upon the second order derivative. Only thing, we come to conclusion that whenever the curve is given at that particular point, if you calculate f double dash of x 0 at that particular point, if it is greater than 0, we can say that directly, we can say that concave of the curve is concave up at that particular point. If you f double dash of x is less than 0, it means that it is concave down. We can, based on this, only we can tell, you will not work out all those things. This is how, why f double dash of x is greater than 0, it is concave up, and our convex, we can say that it is concave down if f double dash of x is less than 0. This is how we can understand how the why this f double dash x tells you the a curve bends. Okay, this is very important.